Hello, everyone, and welcome to today's webinar. Our speaker, Dr. Moshe Bentolila, has over 15 years of experience as the manager of VisiMix's customer support. He holds a BSc and an MSc in chemical engineering from the Technion, specializing in reactors design. He also holds a PhD in chemistry from the Hebrew University of Jerusalem, with his dissertation focusing on practical methods for scale-up processes in the chemical industry. Dr. Bentolila has extensive expertise in technological transfer, having worked as a pilot plant manager and project manager in an API company for over 15 years. Dr. Bentolila has made significant contributions to the field, including his involvement in developing a BSc degree program in pharmaceutical engineering and writing the syllabus for the Pharmaceutical Engineering BSc degree program at the Azrieli College of Engineering in Jerusalem. He is also a lecturer at the college, teaching reactor design and principles of fluid mechanics. We are so excited to announce in this session the release of our latest innovation, VisiMix Sensitivity Analysis, a new software that will enable you to analyze the results for a VisiMix simulation. Feel free to ask any questions in the chat box during the webinar. We'll do our best to address them either during the session or via email afterwards. We hope everybody enjoys today's presentation, and without any further ado, I'll hand the microphone over to Dr. Moshe Bentolila. All yours, Moshe.
Hello, everyone. Thank you, Marcy, for the introduction. I hope you can hear me well and you can see my computer in your screen. If you have any question or problems with trouble with to hear me or to see the presentation, please write in the chat. We'll be able to try to help you during the meeting. Today we are very proud to announce a new product that is coming in VisiMix. The name is VisiMix Sensitivity Analysis. The main idea is to give you more capability to run in one shot more than one answer for some question you have. And in order to do it, I will try to connect it to the general way to think about mixing, how mixing what is the role of the mixing in the industry, and what will be our next step in this kind of activities, that is to provide to you more capability to generate results in a simple operation. For this, I will like to, as you can see in your product, VisiMix Sensitivity Analysis, and this is the forum that you are coming. As you can see, this is the 15th VisiMix forum. So if you come to our website and you go to the events, you will see VisiMix forum section, and there you will find all the presentations with all the new release experience for customers. All what you can think about mixing is there. Explain that people that are our customers or ourselves, that we are together trying to share with you our experience, how to work in this field and generate the best solution for the industry. What we'll do at the beginning for people that are new, to explain a few minutes about the company. After that, only to remind you what is the role of mixing in the industry. And after that, I will explain exactly what is the base of this first release sensitivity analysis that will be expanded during the year, and after that in the next year. So first, VisiMix is a company located in Jerusalem, in Israel. We develop unique software for the industry that enable chemical engineers to be able to understand the influence of the mixing on the process. And once you know perfectly what is your role in the industry, you will be able to connect the main questions you have or the main requirements you have from the company to your activities, and use the capability of the software in order to provide the company the answer that is required for you. Everyone can use the software. It's simple to use, free data generate results, so you don't need to be expert on some algorithms or some numerical methods to solve nonlinear differential equations. All of this is ready for you. No meshing, any kind of thing is required. All is ready. VisiMix is a software that is able to provide to you what is mixing, and for this we use all. We solve the momentum balance to know the velocity of the flow. We use a huge data that we collect in our facilities in order to characterize the mixing during many years, huge experience, about 40 years experience at least. And when we connect one to the other one and we provide a number, this number was proof in all the levels before we release the software. So everyone can use the software in your company and enjoy and take advantage for the results that we are taking. The software was developed many years ago, but every year, every 1-2 years, we continue to develop and generate new versions or new explanation about mixing by numbers that we are doing simulations and try to solve this sophisticated unit operation of mixing. So it was developed in Russia by Professor Baginski and his team, and they came to Israel with this data, and we transfer it in the software that you can use. We have now about 12 products, and we intend to grow more in different fields, in the flexibility to provide to you more numbers in one calculation, or to go more deeply about the mixing knowledge, or to generate some connection between the results and the management in order to give you the best way to answer the company what is really required at your stage. As you know, VisiMix by the end is a software that is dealing with flow mechanics in the steering vessel equipment. So once we connect the results from the momentum balance, that is the velocity, and we integrate the data that we have from different adaptation of models to the steering vessel operation and geometry, we will be able not only to generate power per volume, shear rate, mixing times, we're able to connect it to the main and intuitive parameter that every process engineer would like to know and to keep fixed. For instance, solid distribution, mass transfer coefficient, heat transfer coefficient, all what is required for it. So the software will give you a very good idea about it. Some customers working with us that are in different fields in the industry, as you can see, pharmaceutical, fine chemicals, agronomical, formulation, all the fields that you can find steering vessel, you can use software in order to generate results that are giving you a capability to be effective in your answer and be significant in the results to the next step. Dr. Victor Timoben, we remember always him. He was one of the pioneers to use the software and because to be expert mixing expert in Dow Chemical. Now he's retired. Maybe he's here hearing us. Always we are grateful from him. And he was advising to use the software in the company and of course continue to be expert. So want to consult him, maybe we'll be very happy to have some chat with him. Now we grow, and now we are more than 350 companies working with us in different parts all over the world. And feel free to contact us, every one of our account managers. We have here present people that are in US, in Europe, in India or Asia, and all of them will be very happy to answer you. Contact us from our website, from the LinkedIn package, LinkedIn profile, and once you will have any question from us, we will connect with you for more details about how to progress, even it is coming from the customers and getting some customer support or new customers that would like to know about this. Okay. As you remember well, the motivation of the use of the software is simple. Once we have some question coming from the management regarding the request to generate more material or transfer the process to other site or design a new equipment, we have a lot of questions. But if we focus ourselves about what is really required, because in this step we normally have some knowledge about the process, the quality, the raw material quality, and the operation, and we succeeded before that, even in the lab, the production early step. We know that this question is coming in a frame that the answer will come if we will be able to manufacture in the same way in different geometry of equipment. So once we know that the main change is coming from the different geometry that will be reflected in different environment where the materials will interact between them and generate our process and our product, we know that when we know what are the main important mixing parameters that are generating this interaction between the materials in different equipment, we will be able to answer which of the equipment will be good for us, which of the equipment will be not good for us, and which of the situations or the scenarios will be not enough knowledge. We don't have enough knowledge in order to progress. So this is the motivation to use it. This is the role of mixing in the industry. Our mission is to provide the answer. Yes, not, we need to do this change, or we need to analyze in this way, or to go deep in these details. By then, we'll sit together and we decide in the company to progress to the next step according to the knowledge of the process and according to the interaction with the equipment that is available for us or we design for it. Okay, this is our job. This is your job. So it is possible to know from every step how to work from the lab. If we know where we'll be able to design, manufacture, and justify what we are doing. All of this you remember well. And by the end, if we define what is good mixing, the answer is the fact that you are working in the industry. And once we are working in the industry and we have some deviations, for instance, in this case, some defect or some problems in one of the equipment and wanted to replace to other one, we can see when we talk about some non-homogeneous process, you can see here chemical non-homogeneous process in bits, that we design a new equipment. We directly identify that the new equipment is not giving us good results, and by some surprise, if we decided that the solid distribution is important, it is not equal, that should be homogeneous. In this case, the older equipment generated results that when the solids were not well distributed in the tank, the quality of the material at the end was very good. And when we designed this new equipment that was not good, the answer, the quality was not so good, we detected that the reason was that the solid distribution was more homogeneous, but this homogeneity generated more interaction with the heat space, that the oxygen that was in the heat space react with the part of the material that was in the top of the equipment and generate an impurity that was impossible to solve. So what is the good mixing? Is the capability to generate good quality, productivity, and without problems in operation in the industry. And not always will be high velocity or homogeneity. It's really depending on the process. It's really depending on the interaction between the materials. The range of work that we are analyzing that will give me good or bad results is something that should be analyzed during our activities. So not only to know that we work in the lab well, what is my equipment available, and what is the range of work. We need to know inside this range of work, inside this operation of the process, what will be the mixing that will provide me the best results. This will be able to do now with the sensitivity analysis. Okay? So this company says about millions of dollars more, and you are familiar with it. You know what is the meaning of a good decision at this stage. As you can see here directly, the last equipment, it was two zones, so the solids were mainly in the bottom. in this new equipment, the solids were well distributed, but we have many solids in the top, and this was not good for the quality of the process of the material. Okay. And of course, we discuss about the proposed method. The main idea in the proposed method, let me only show to you, it was to connect between the data we know from the lab, so the reason for any deviation we can maybe experiment, what is the equipment we'll use, and try to set up the equipment in the mixing parameters that will generate the same interaction between the materials in the smaller scale as possible in order to be sure that we are evaluating the process as small as possible in the same range of work that we will meet in the production step. All of this we discuss always, so it is not new for you. It's only to remind you to give you a good idea. Now, of course, this presentation will send to you, and you will be able to read more and interest. If you want to have this presentation regarding sensitivity analysis to your company, tailor-made to your company according to one of the data that you have, only to show that it's possible to work, of course, contact us. We're very happy to provide you. Now, VisiMix sensitivity analysis. What is the software doing? The software, the sensitivity analysis function, the main use is to compare the characteristics of a specific process selected by the user. So the process we have conducted in some equipment, and inside the equipment we want to know the sensitivity by changing the operation. Okay, it can be the RPM, the volume. Okay, all the parameters in this mixing tank at this stage, in this first release, will be for one parameter input, and all the outputs that you're looking for, depending on the unit operation, we'll see. And the user should select the sensitivity variable from the list of variables that we decided to provide, that is mainly focusing at this first stage in the operation of the software. Because what happened many of the cases is that you want to change the RPM to see what is the range of work, to avoid solid non-homogeneity or solid deposition in the bottom, or you are changing, you are feeding one material and a second material and a third material, and every addition is changing dramatically the level of the media, and you want to know what is the deviation in the mixing, how to correct the mixing according to what you know. This kind of situation we are doing, and many others according to the unit operation. The sensitivity analysis function can be used to select the optimum. So once we are doing all this range from the minimum and maximum, we will see that the results are giving me all. It is not only the drop size. It's giving me all solid distribution. It's giving me the solid distribution, but all the other parameters regarding to solid liquid. So the solid distribution, axial, radial, the frequency of collision, the complete or incomplete suspension, and below that, we can find the power per volume, the mixing time, all the main important parameters that are connected to the solid liquid phenomena that are very frequent in the industry. Of course, we can run one time for solid liquid, another time the same equipment for liquid phase, single liquid phase, and combine between them. Okay, but at this stage is an input that will give me many outputs that can be important. As you know, mixing is multidimensional phenomena, so we need to take in consideration more than one parameter. We need to take in consideration the multidimension, the local mixing, the zones, and the integration of all the flow and direction that is required in order to generate the mixing that we are looking for. So the outputs are the outputs that we generate is a big table. Okay, that will be more bigger in the next step, but a big table that is giving me at least 12 columns showing me my source, and after that all the sensitivity analysis. Okay, and what are the operations that we're talking about? What are the same operations that you know from the process analysis, that are single phase emulsification, liquid solid mixing, or mass transfer, gas dispersion, heat transfer in different ways. And of course, we can change the basic. It is based in the basic mixing equipment, and we can change according to all the versatility that we have in in the VisiMix software. Okay, so this is the scheme, how we are working. Open and generate a project. This will be a master for us. Start the sensitivity analysis. Select the unit operation that you're looking for, solid liquid, liquid liquid, liquid, etc. Select what is the input parameter you want to change, to sweep. Define what is the range from the minimum to the maximum you want to go. And when you click there, the software will run automatically from the minimum to the maximum and generate the results. You will see the results, and if you activated the bottom, you can see some message that the software is giving you in the results. Of course, if you ask to calculate something that is outside the capability to calculate because it is not good mixing practice, you will see that the answer will be marked with some X, some notifications that tell you that at this kind of range, the operation will be not able to do something that will be we will be able to take in advance result from it. Okay, and export the results to Excel, to any place I will show to you. So create the master manager, select the sensitivity analysis, select the operational parameter, select the range of work. You see the master is 125, but I want to know what happened between 10 to 20 to 25. Okay, and what will happen? The software will run all the way, and you see pass the meaning of the pass the test, and we can generate result. In this case, all pass the test. If you want to see at every test you have some notification, you will see. If you deactivate the disable message, it will run, and in the table you will see the notification, the warning, all what is required. Okay. This is the output result. It's very similar to the output result for the process analysis, and it was our intention, because you will see now in the demonstration that will open, and I will manage all from the beginning. You will see how it's important first to know from the lab to the production how to work, and after that how to establish what is the range of work in the lab or in the production to compare between them. Okay, so this is the main idea. The next step for this complete project, we are only starting. Okay, we have more news. Okay, but we are only starting with sensitivity analysis, one independent variable, and it is now happening. We are releasing VisiMix Turbo in 2025, and inside you will find the sensitivity analysis study. The next step, once we finish to do all the activities of the QA and all what is required for release, that it's now, you can start to ask your account manager about how to get it in order to prove and in order to operate, to get some a starting point, of course, quotation for the next step. The second step will be to run more than one. In this case, it's two because it's a simple one, but it's more than one. And the latest step, the next step for this complete project is to have a capability to have some discussion between VisiMix software and your questions. That it is reminding us some AI. Okay, so you will be able inside the software by some software that we are trying to generate to try to generate some discussion between you and the VisiMix models. Of course, it will take time. It will be during the next year, but our main intention is to incorporate VisiMix in the discussion in the company. If you have AI or you are getting data from different kinds of platform you have, from chemistry, physical properties of the materials, or from the chemistry mechanism or biological mechanism, you will be able to discuss with VisiMix together. Step by step, we'll start this one, and we're very optimistic to continue to go to the next. From here to the end of the presentation, you have more examples that we want to share with you. Of course, I will not cover them, okay, but we will send to you in this presentation regarding crystallization, regarding gas liquid systems, and examples that we had from his or she rate and high velocity. Okay, only to remind you, you know, okay, and if you are new and it is the first time you hear about VisiMix, please contact us and we'll be very happy to have a presentation to your company, give them more about this sophisticated unit operation that is so critical at this stage. And you have now a capability to, in a simple way, generate the numbers that will give you a confidence that your advice, your input to the company will be more relevant and specific. So this is the line of product we have now. I need to add now sensitivity analysis. The last time that we generated, it was VisiMix Chem, that is continued to be an innovation. Try to use it, is combining between the the kinetics of the reaction for up to 5 reactions with the realistic situation in the flow mechanics. Okay, we are talking about in the liquid phase. We put our materials because we have no the same level size of molecule in comparison to the minimum fluid element. This deviation can generate a deviation in the results that coming from the intrinsic non-homogeneity that is coming from this fact, and the levels of the results can come from the complete analysis of the flow into the tank, and to go more deeply to the lower constraint that it is the eddy size. All of these were solving in the VisiMix Chem, and it is based in VisiMix models anyway. Okay, so you can use it as the last product that we release more deeply. Mixing this release now is more to try to start to open the capabilities to generate more results in one click. I will show to you, and after that to try to generate some discussion with the software that the software will answer according to the models we have inside. Okay, so all the explanation about our products you can find here. This is the last part of the presentation. What I will do now, I will open the software. I will do a complete round, laboratory, production, etc. And I will implement the sensitivity analysis operation that gives you a good, in order to give you a good idea about how it's working. Of course, you are invited to come to the website. You will see more about every product, including this one. Remember that your mission in the company is important. The decision that you are taking can generate a complete line of production or travels. That if it's in the stage to transfer the process to the production stage, it can be enough no good in order to stop, okay, or to lose customers. So this input is very important. The role of mixing on this stage is very important. You feel it, you have the capabilities to do it. So take an advance and progress. It is fast. The models are proof, are really a coordination of all. It is not only the solution of differential nonlinear equation by some numerical methods. It is not pure mathematics. VisiMix is not pure empirical data. We are not very thin in some empirical data. No, we are giving to you a complete model, complete scientific and industrial model that gives you a capability to enjoy from the mathematics, enjoy from the empirics, and enjoy, of course, from the customer support. Our customer support, as you know well, we are people that we work many years in the industry, and we are deal with these activities for our customers, try to provide to them through the software and the customer support all our experience in order that you will become to be expert in these issues, scale up, mixing, design, and all, and to give the company what the company expecting from you, that is a good advice. So this is the conclusion that I explained now. Not only simple software, our results are based, and it is not only empirical or mathematics. It is expertise on mixing that we want to provide to you. Okay, so we finish this part now. I will open the software and start to operate according to what we wanted. We have a question here. Before that, I see you can define the range for the sensitivity analysis. Can you define the step? Yes, we can define the step. I will show to you in a few seconds. The main idea at this step was to have some run that can be in the complete range, or to do 12 step in short range and to continue to do this 3-4 times, so you will have all in very few seconds, or to define 2-3 steps. Okay, this is the first release. Of course, in the second release, when we have two parameters, we like to include a more different kind of steps that will be designed by some string and not by equal distance between the parameters. But let's start to work. Thank you for the question. Let's start to work. Okay. So what I will do now, you see here now we have turbulent two versions. You see I have two versions. If I come to here, you see is VisiMix 2025. This is what you will receive with sensitivity analysis, and you can see here sensitivity analysis. Now the first I will do, if I will open a new, generate a file that you know well, let's say some lab equipment. Okay, and I will do it very fast because you know it well. I will select my tank that can be with jacket or with no jacket. My lab equipment nominal is 1 liter. The diameter of this tank is 100 milliliters. And the total volume that we have inside my tank, the material that I want to feed, to mix at this sample is 100 milliliters. When click OK, the software asks me we have buffers. Let's say I have two sensors, one pH and one temperature, so we have two. It's like a buffer, okay? The width will be 10, the distance from the bottom 20 millimeter, and the distance from the wall 8 millimeters. So my lab equipment, we have these two buffers. Once we click OK, we have an impeller, very typical one. I will use pitch pedal, as what you can see here. We have very typical one from radial and axial and between them. Some prototype for generic for the iron foils, some other special equipment, and some equipment that are coming from the glass line. Remember well, but the main important point is the geometry of the impeller. Okay? So we have here about 20-25 different geometries of impeller that are covering mainly what happened in the marketing thing. Anyway, if you feel that you want to be more precise, you can use alternative impeller. It's some kind of customized by using some data from the literature regarding to the power number that is coming from the geometry. So you can contact us and send us the drawing of equipment, and we'll be able to advise to you how to progress anyway. But in our case, I will use a typical one that's pitch pedal in the lab. It is very typical in the lab. I will use single, it can be multi-stage. In this, I will feed the data for my impeller. Okay, 50 millimeter, 4 blades, 45 degree, 10 millimeter width, a distance from the bottom 20, rotational speed 600. I want to be turbulent in small equipment, so turbulent required high velocity, and 100 watt. This motor power is only required to protect your equipment. We calculate the mixing power required according to all. Once we click OK, the software asks me now the process, density, or viscosity. In this case, I'm using water, okay? But you can use any material, even non-Newtonian media. So the rheological that would be non-Newtonian with two different kinds of models. I will use Newtonian one, and I will use water that it is 1 centimeters. You see, we finish this laboratory. We can calculate what we want. In my case, okay, if you remember well, we can calculate what we want. You see any number, I click here, I will generate the main important mixing parameters, local, general, and mixing types. But it is normal. Now, let's say I have some solids inside. I want to have the to know what is the solid distribution. For this, the software is asking me more data about the liquid, the pure liquid I'm using, the concentration of the solid phase, the density of the solid phase, and the particle size dV50 and dV95. Okay. Because in this case it's batch, I am not taking the material as continuous flow, but if it is continuous flow, we can use the position of the output stream in order to calculate the concentration there and to do some mass balance. Okay. Once we click OK, the software detects that we have some deviation because we fit some solids. We click OK, and we get the solid distribution. Our case is 10%. The deviation from the average to the bottom of the tank is about 1.1. So the local concentration divided by the average concentration. So we have 10% more material in the bottom of the tank. All of the tank. Until now, you know it. VisiMix standard, no problem. Other point that you know is if I click scale up, scale down, I can go now to an equipment that will be 6,000 liter. The software gives me by geometry similarity the diameter of the tank. And if I want to have the same solid distribution, I can ask the same solid distribution is giving me the velocity I need to apply in the big equipment based by geometry similarity to generate the same solid distribution. So once I click OK and give the name of the prototype, because it's the same geometry similarity, the same geometry but big, okay? Okay, sorry, different name. It's giving me the prototype, the same geometry, big one, and if I calculate here what is the solid distribution, it's giving me, okay, remember that you have some deviation because you use some solids, and you have here the same curve, and it is scale up, scale down. Of course, we can click process analysis, and we can get the connection between them. Until now, we know it, okay? But we are in the realistic life, okay? So my prototype is exactly the same as in the laboratory, but you know well that it is not normal situation. In your real life, you have some deviation from the prototype. Once you calculate the main point for the equipment, you want now to change the tank because it's not the tank. Normally, it's not copy paste. So for this, we can come to the icons that are changing the design. So let's say my tank now is elliptical bottom. And let's say my diameter is 1,900, okay? 1,900. And the volume that we have there is continue to be 6,000, okay? And the actual volume that we have inside is 5,000 because my real life. Now it is my equipment. Now, we have instead 2 buffers, we have 4 buffers, and the width of the buffer will be 180, okay? Now when you click OK, this is my equipment, okay? And my impeller, I want to change instead to be pitch pedal because it was not. But in my tank, I have some hydro for lighting, for instance, that the diameter is 900, the distance from the bottom is 450. The rotational speed, I will use the smaller one, the 33 is what I got from the scale up advice according to the geometry similarity, and the motor power that I know from my equipment. So this is my real life. And when I calculate the solid liquid, okay, what we have is, oops, we have complete suspension is questionable first, so this is not the same. And the second, if you remember that we have deviation of 10%, now we have deviation of 20%. So now I want to know what will happen when I change the RPM. I do all the screen from the minimum to the maximum. For this, I go to sensitivity analysis, and we can select. You see, you have single phase, emulsification, liquid mixing, liquid solid mixing, solids, or mass transfer, or gas liquid. All the parameters are required for any one. So I will use, in this case, liquid solid mixing. And now I can select the level of the media, or the RPM, or the concentration, or the particle size. In our case, would be completely operation, the RPM. This is my master. This is my tank. I will do, for instance, from 20 to 120. Okay, let's say this is 6,000 liter equipment. This is a range of work, the maximum range of work. Okay, now if I don't click the cyber message, I will get every time the notification about the solid distribution until the RPM that we don't have this problem. Okay, but I will deactivate because I want to run smoothly. Okay, so when I click run here, You see, all the calculations were done, finished, and now we can see our results. If I display my results, you see now all the results. This is my prototype and all the results. What is important here for me? The first is you see that is the complete or incomplete suspension. Okay, is incomplete. Oh, from 56 to 65 RPM. Now we are coming from incomplete suspension to complete suspension. Okay, more than this, you see that the level of homogeneity, you remember it was around 10, is now around 10 again. So we are there. We are there with no problem with the solid distribution. So we need to at least increase from 53 RPM to 65 RPM. Now, if I take this data I have, okay, you see we have two tables. And now in the process analysis, okay, what I did before that, okay, I take my file, this new file, instead of 33, I go to 66, and I do my process analysis, okay, and now I bring the lab, the prototype, and my new project, because I detected with sensitivity analysis what will be the RPM. When I click on peer, I have now three columns, one with the laboratory, the second was the prototype, that is geometry similarity, but it's my real life. And I'm not so far, I'm good. And not only this, if we see all in one page, you can all the data in one, okay, you can see it in the bottom, mixing, macro mixing time, power per ball average and maximum. And if you go in the design, okay, mixing characteristics for the design, you know exactly what is the RPM that you are using, okay? So this is now the way to do all of this combination. Of course, from here, from the sensitivity, from the process analysis, or from the complete sensitivity analysis for the specific equipment, we can generate export to Excel. We can give some name, okay, and we can come directly, okay, it was generated, and we can come directly, okay, to our VisiMix Excel file, and we see here all the information, the complete results, okay, the design, the properties of the media, and the properties of the input that we are doing, the mixing characteristics, and all in one, that I show to you all the results in one page for all the results here, and you can see the actual and actual distribution for every one of them, okay? So you can print, you can see every one of them. I want to show to you. Let me come to here. If I come to here and show the actual distribution, you see here all the actual distribution for all the runs, okay? All the runs. The first is the first file, the source, and all of them has all the runs. So we have all the runs in the relative concentration from the bottom to the top, okay? And the same for the radial, exactly the same. All of them are the same, so the radial have no any deviation, significant deviation. In the actual, we have some deviation that, of course, from here we can know that maybe this is the reason from the deviation in my process, okay? So this I wanted to show to you. I'm collecting here some questions from the audience. The last the question before that was from Dr. Cliff Cowell. Nice to hear you and see you again and again. It's nice to see that you are here and you are taking advance all. We're very happy to be in contact with you. The second question, greetings. It is possible to input raw material characteristics and based on that can get equipment process requirement in terms of design? Yes, as you see, it's very fast. We click, we generate fast results, we generate tables and notes, so you can design in very simple way. The point is here that when we talk about design, you have not only one solution. You have all the range of all solutions. Okay, so when we talk about design, and if you are a designer in a company that design equipment for the customer, you will like that your customer will be happy with your design. And the main and starting point should be what they need for their process. And it is typical from our customers that are providing this kind of answers to their customers is that maybe the customer is not so clear about what is the sensitivity of the mixing their process. Okay, so be sure that your customer is aware that you are providing some answer for the specific question they are asking you, or try to guide them to generate more knowledge about the range of work that will be possible to run. Okay, because as I explained, as I showed to you now, when we go to scale up, we are doing some activities about the same solid liquid, but after that we have problem with the position, or we problem with the mixing time, other, because it's a multidimensional phenomenon. So take care on it. Okay, in points of view design, we need to design in a range of work that will be good for my process, and not always is high velocity, high shear rate, or homogeneity. I explained in the presentation, in the motivation, I showed to you how when they decided that the solid distribution should be homogeneous, is good for the process, and the answer was that the process was not good. Okay, so mixing is a service. We are serving the process. So because this, we need to ask the process what is the main important interaction between the materials you need to generate, which kind of interaction you need to generate, and it is coming through the mixing that you are providing to the process. So the answer is yes, because it's fast, but the sophisticated answer is take care about what is really required. Okay, you have any other question? Okay, so thank you very much to be with us. It was a pleasure to meet you again. We have another question here, maybe. Yes, another one question. Is it possible to use scaling up from lab to plant scale with the simulation factor? Yes, but simulation factor, when you are talking about simulation factor, normally you are talking about one parameter. Take care when you are doing it, other parameters should be similar. Okay, if I do a scale up factor for mixing times, okay, who tell me that the solid distribution will be the same? And maybe the solid distribution is critical, or the mass transfer, or the drop size. So take care on it. This is not a way, because it's multidimensional phenomena, it's not a way only to be reducing one. We can start with one, and we need to see what is the deviation for the other, and ask, okay, I did this one, the other is far 2-3 times. Now, is good for the process or not? For this, we need to ask the process. We need to find some data that is supporting my decision. Okay? Okay, so thank you very much. We will upload this presentation, the recording, the file that I use, the presentation. We will upload some training about sensitivity analysis in YouTube channel, and contact us, and we will be very happy to share with you what is possible to do with the tool, and to progress with next step, contact our account manager. Okay. No, we have another question here, small one. So basically, my lab scale equipment should mimic plant scale equipment? No, should mimic plant mixing characterization. No, not the same geometry, the same flow, the same mixing parameters, the same interaction between the materials, yes, as possible, or the same critical mixing parameters that are controlling the process, yes, but of course not the same equipment. We cannot, normally we are not doing copy paste of the equipment. this is not the situation. Okay, so thank you very much for your time, and we will announce maybe in 1.5 months we have another meeting because we have another product that we are releasing now regarding to more deeply knowledge about mixing. Okay, not simulation, not organize the data, more about support and training, and it will happen around 1.5 months from now. Thank you very much for your time. I hope you enjoyed the meeting, and it's a pleasure to be with you again and again. Have a good time. Bye-bye.